So we're doing 1/4 today. And we're starting with some function operations. Okay, so I've got all of these operations. We're adding, we're subtracting, we're multiplying, we're dividing, and it's up these functions up here. So I've got 4 functions up here that we're worried about. I've got f of x, I've got g of x, I've got h of x, and then I have p of x. So those don't really worry me too much. I'm just going to use them to do our operations. When I'm going to add my 2 functions together, does that make anything funny happen? No, we're just going to add them up. We're going to just go 3x plus 2 plus x squared minus 1. You can throw parentheses in there if you want, but at the end of the day, it's not going to affect anything. We're going to combine any terms that we have, and we're going to put it in descending order of our exponents. So we'll start x squared plus 3x, and then we can combine our 2 and our -1 to get plus 1. That's it. Don't factor, don't solve, don't do anything else crazy. That's our answer. Now, it does ask for the domain of this. What's the domain of this function going to be? All reals. Negative infinity, positive infinity. Were there any red flags in that? Any square roots, any fractions? No, but if it's just a square, it's all real numbers. Nothing is different, nothing's crazy. Okay. Next, I'm going to do h minus f. Bring that over here a little bit. So we're going to do our h, which is 2x, and we're going to minus f. Now, in this case, I am going to use parentheses just to keep everything organized. When I minus, I need to make sure that the negative goes both to the 3x and to the 2. So we'll go 2x minus 3x minus 2. Combine any terms that we have, in this case 2x minus 3x, so negative x minus 2. And that's it. What's my domain for that going to be? All reals. Very good. Negative infinity, positive infinity. All right, now we got to do some multiplying. So I'm going to multiply f of x and g of x. F of x is at 3x plus 2, and g of x is that x squared minus 1. The biggest thing you got to remember when we multiply like this, you got to distribute to everything. You got to FOIL. So I'm going to do FOIL for all of this. So I've got 3x to the third minus 3x plus 2x squared minus 2. Technically, you can't do any combining here, but I do want to reorder so that I have them in descending order of exponents. So we'll go 3x squared plus 2x squared, or sorry, 3x to the third plus 2x squared minus 3x minus 2. Put it in order like that. All right, what about my domain for this? All reals. Nothing new, nothing different, nothing crazy. Next is going to add a few things. It's got h times p. So we're going to multiply 2x times the square root of x. 2x times the square root of x. Now, when I go to multiply those together, can I simplify that any? Can I combine anything together? Or do they just still stay next to each other? They still just stay next to each other, right? They're still going to say 2x on the outside, root x on the inside. I can't make that any smaller. However, I finally have a red flag that I've got to deal with this domain. What is wrong with this problem, or what do I need to be aware of? The square root. And what's under the square root must be greater than or equal to 0. So I know that I've got an x on the outside. That doesn't matter. Anything that I plug in must be greater than or equal to 0. Again, you can use your number line to help you put that into order. But at the end of the day, we've got the domain of what? What's my domain going to be here? Good. Bracket or parentheses with that 0? Bracket. Very good. I can put 0 in. I can put 0 in. All right, and then the last one is going to be a fraction because we're dividing them. So that's going to be a red flag that we have to look at. We're going to do h over f. So h is that 2x, and then f is 3x plus 2. Now, a lot of us get to this point, and then we want to start simplifying. You're like, oh, well, I see a 2 on top and a 2 on bottom. Cross them out. I see an x on top and x on bottom. Can I cancel any of those things out? No, it has to be the same in all three of those terms. I need a 2 or an X in all three of those numbers, then I can take it out. So this is actually one of the easier ones because I can't do any simplifying here. That's as good as it gets. However, I do have a red flag to worry about. What's my red flag here? The denominator cannot do what? Perfect, cannot equal 0. Good job. So I'm going to start solving that. I'm going to minus 2 from both sides. I'm going to divide by 3 on both sides. So X cannot equal negative 2 over 3. Now, do I care about the numerator here? No, why not? It doesn't have a radical. I tried to correct those of you on your quiz that we messed that up. The numerator can be whatever it wants to be unless there's a radical. The radical is the only issue that I have. So if there's no radical in the numerator, I don't care about it. So on this, everything is good except for negative 2/3. And so we'll do our interval that way. Negative infinity to negative 2/3, negative 2/3 to infinity. Do I have any brackets in this at all? No. All right, so that's a little reminder of the domain of all that stuff that we've been doing before this. Okay. I probably haven't done attendance yet. Okay. Pause. Now we're going to do this, but we're going to be doing composition of functions. Is composition of functions something that you've heard about before? Yes, no, maybe. This is where we put one function into another function. I'm going to put function f into g or g into f. I'm going to put one inside of the other one. So I need to make sure that I'm going to know what's on the inside, what's on the outside. And then if there's not an X, if it has a number, then I'm going to plug that number in for the X. So we'll start with the first one. It says P bracket H parentheses 1. Okay. This we read, and you don't have to write this if you know how to read it. It's P of H of 1. The number, the fraction, or the function that's on the inside of the parentheses or bracket is going inside the other one. So in this case, H is my inside function. P is the outside. And so I'm going to take the X that's in P and replace it with the function. So P, if you remember, let me go just double check, is your root X. So instead of doing square root of X, we're doing square root of H. So I'm going to put H inside of this. H was, I think, 2X, wasn't it? Mm-hmm. And instead of putting 2X, we're going to do of 1. So I'm going to put 1 in for that X. Now, I probably have too many parentheses here. I probably don't need that parentheses, and I probably don't need that one. But you're welcome to keep that if that makes you happy. And so when I do this, I'm going to do 2 times 1, which is 2. And I've got the square root of 2. Can I simplify that anymore? No, that's a number. That is an okay answer for this composition of those functions. We put 1 into H and we put H into P. And I ended up getting root 2. Okay. Let's do another one. Now it says H and then it has that like open circle F. That's the same thing. H of F of 2. The function that's in parentheses or the function that's second is the inside function. So again, I'm going to have 2 on the out. My 2x is going to be my H function. But instead of doing X, I'm going to put inside my function F. And our function F was 3x plus 2, I think. Yep. So we put F into H. And I'm now going to put 2 into F. Instead of putting X, I'm going to put parentheses 2. You guys all okay with this? Does this ring a few bells from Algebra 2? Okay, no? Okay. All right, so let's start solving. We're going to do PEMDAS, just like we've done every other time. We're simplifying this. We'll multiply our 3 times our 2. 6 plus 2 is going to be 8. And then 2 times 8 is going to be 16. Oh, sorry, what? All right, okay, we're good. Okay. No, this maybe feels funny to you. Maybe the other ones we're about to do maybe seem more correct to you. On the next few, they just have x's, they don't have numbers. So we're gonna just plug the function in and we're gonna get out an expression. So when I come down here, this says h of f of x again. So f is my inside function, and we're just gonna put that inside of h. I can't see mine anymore, but I know h is that 2 times x. Instead of writing x, so we're gonna put our f function, which is our 3x plus 2. But this time I don't need to put a number in because it says x. So I don't need to put anything in. I'm just going to leave it as x. And now I'm just going to simplify this. I'm going to distribute. I'm going to combine like terms. I'm going to call it a day. So 2 times 3x is 6x. 2 times 2 is 4. 6x plus 4. Okay. Everybody okay with that? Let's do the same thing for the last one. This time it shows you that you don't even need an x there. It still is f of g, which is my inside function. G is inside of f, so we'll do our 3x plus 2, but instead of x, we're going to put in g, and I forget what g is, x squared minus 1. Again, distribute, combine like terms. I get 3x squared minus 1. Any questions so far? We doing okay? All right, go ahead and turn your paper over. Now I have directions that say find the 2 implicit functions and sketch. I assume we've never heard the word implicit. Am I correct in that? Implicit means implied. Do you guys know what implied means? Like if I say it's implied that, I don't know, you guys are quiet while I give notes, or it's implied that, I don't know, it's homecoming because we're all dressed up. Implied is like it's not like explicitly said. It's just expected, suggested, assumed, those kind of words. And notice all of these have kind of the same idea here, and this is what I'm going to show you is why it's assumed or why it's expected. Half of them have an y squared. Okay. The other ones have an absolute value. The way we know squares and absolute values is where we get that implied second function, okay? So let's look at, we'll just do this first one first, okay? I need to get y alone to get a function. So let's minus that x squared from both sides, and then we'll square root that y so we can get y all by itself. As tempted as you might be to simplify this, you cannot simplify x squared plus 25 because there's a plus on the inside. They're not being multiplied together. So it's not it's not like 5ix. That plus sign in there means that we can't actually simplify anything. Now, because I did a square root on both sides, what do I need to put in front of that? Plus or minus. That is implying that I have 2 functions. And you can leave it as just the plus or minus, but I like to write the 2 separate functions so I know what's going on. That implies that I've got one function that's y equals the positive square root of negative x squared plus 25. And I've got another function where y equals the negative square root of negative x squared plus 25. Can you guys remind me what a square root function looks like? Can you show me in the air, what does it look like? Square root.
Oh, wait, no,
That's an absolute value.
wait. Oh, wait, it's a.
Yep, it just kind of zoops over to the side, okay? So what this is implying is that the way that the square root is working, if this was just a normal square root function, if I have the positive that's on top, the negative is on bottom. Is that a function? Does that pass? What's our test to decide if that's a function? The line test. Does that pass my vertical line test? No. The way we get away with this is we call these 2 different functions. I've said I've got one on top and I've got one on bottom, so because they're two different functions, they're two implied, implicit functions, then it's okay that we have them both. Okay, let's actually go graph this really quick because it gives us a really cool picture, and I'm just gonna kind of geek out for a little bit. If you don't like it, then that's all right, just feign interest for me, but I think it's gonna get pretty cool. I think I have it all set up already. So we're gonna put one. In one of my y's, in my y1, I'm gonna put square root of negative x squared plus 25. And the other one, I'm gonna do negative square root of negative x squared plus 25. Who's ready to see this graph? It's pretty cool. Let me make sure my window's fine. It does make a circle. Wait, I didn't do my window right. Circle! Look at that! Mine is pretty, isn't it? Do you have a standard window? A -10, +10 window? Now,
It's the USA code.
it's the USA colors, very on brand. Now, can you guys remind me, what is this equation for? What equation is that? What equation is x squared plus y squared equals 25? Remember learning about that? It's a circle function. X minus h squared plus y minus k squared equals r squared. That is a circle function. My center of that circle is at 0, 0 because I don't have any points in here. And then the square root of 25 is 5. So that is that perfect circle that we've got right there. Isn't that pretty cool? If that was all one color, it would not be a function because it wouldn't pass the vertical line test. But because we're saying that it's two separate functions, one's on top and one's on bottom, then by themselves, they're each functions and together they make that circle. Okay? Whenever we have a y squared, it's going to be a circle equation and it's going to be simply as, actually we have to have x squared and y squared for it to be a circle, but it will make that circle. If you have a y squared, it is an implicit function and you just have to have a plus or minus in front. So we're going to do the same idea on this one. Let's go ahead and graph and solve that. Let's get the y squared by itself. And then I promise that's not going to be a circle, but it'll be a pretty interesting graph too, I think. And because it was y squared and we have to put that square root in ourselves, then we need to put a plus or minus in. You can always just leave it as y equals plus or minus square root of this, or you can make two separate ones. The positive square root and the negative square root. Okay, so let's go graph this. The only difference is I just don't have that square in there. Square, get rid of that square. Let's see what that looks like. Oh, what do I have a 9? Interesting. Can I zoom in and out maybe? Go at least to like 30 or something. Oh, there we go. That kind of looks like maybe more of what we were expecting. This is a nice little sideways parabola. That again, because I've got one function on top and one function on bottom, they're allowed to be separate functions. All right, I've got one more like this. Letter D, solve square root both sides. Give your plus or minus. Now you can simplify that. We're going to look at the graphs, and I did mean to ask somebody else about this to see if I was doing it right or wrong, because you'll see slightly different graphs when we graph it each way. But I believe those cancel each other out, so it's the same thing as plus or minus x. But if I go to graph it, it will give us slightly different numbers. So let's show it this way. Square fault there. Square fault. So I've got plus or minus root x squared, root x squared. And when I graph those, that's pretty cool. Come on, window. Act better, please. That's pretty cool because it kind of looks like an absolute value on top and an absolute value on bottom. Now, when I simplify it to look like this, it just gives me two intersecting lines, which is not nearly as cool. But it still gives basically the same graph. Okay, positive. So when I do it this way, they're just intersecting lines, but the other one looked like two absolute values, which was kind of cool.
Same idea.
Same idea. It covers all the same points, right? Okay, now those, say one more time. So the y squares are interesting, and the reason they're implicit is because why? Why are they implicit? Why do I get two functions out of it? What's the key thing here? The plus or minus that goes with the square root. So on this one, the most important thing I want you to remember is that plus or minus. Plus or minus, okay? Now, absolute value is going to be a little bit different, okay? So let's go ahead, let's solve, let's get that absolute value all by itself. So we'll minus that x from both sides. Absolute value of y equals 1 minus. Remember when we have an absolute value, one way we do it, we keep it the exact same. We just get rid of the absolute values, we keep it the exact same. The other way we do it is that we change it to negative, okay? Normally our absolute value is over the expression and we change the number that's by itself to be negative. In this case, it's the same math. I'm just going to make the y go negative, so it's easy to make sure that everything gets the negative or gets changed its sign, okay? Y equals -1 plus x. I know when we do absolute values, what it's like absolute value of x minus 3 equals 8. We set it equal to positive 8 and we set it equal to negative 8. And we tell you don't change anything inside here. It's because we changed the outside. This time, because it's harder to change the expression, we're just going to start by changing that left side and then we'll move that negative over. It does the same math. Okay, so this time I've got two equations now. These are two, what kind of functions are these guys? Linear. So those are two lines. If I graph them, they'll look a lot like what we've got going on right here. Those are two linear equations. It's not as simple as a plus and minus before, but we keep one the exact same, and then we change the other one to be opposite signs. And those are my two implicit functions there. Okay, let's do the one underneath it. And then if you guys are dying to, I can graph them, but they'll just be lines. Minus that x from both sides. Divide by -1. And then now when I do these two separately, they're going to give me the exact same equations that I have above. But one, I keep the signs the same. The other one, I switch all the signs. And again, these are the same equations as you see above. They're kind of opposite of what they were. That one goes with that one, and this one goes over there. But it's the same idea. And again, I can graph them -1 plus x and 1 minus x. And those just give me two lines that intersect. Okay, are we feeling all right about those? Anybody have any questions for me? Okay, we got two more tiny problems. This is not as big of a deal as the other things that we've learned, but it is in this section. We did composition a second ago. Now we're going to do decomposition. Composition is when we put them together. Now we're going to take them apart. So let's look at letter B. I think that's an easier one to see them taken apart. If it says f of g of x equals this, what's my f of x? What's my g of x? Remind me, which one's on the inside? Is the f or the g on the inside? G's on the inside, so what's my inside function here? Oh, sorry, look at the second one. I think it's easier to tell. X plus 2. That's my inside function. X plus 2. That being said, what's my outside function then? X squared. Because I put x plus 2 inside, when I take it out, I'm still left with an x and I gotta square that.
Did you count us off and do the little like X? Like we only wrote like, I think it was an X squared.
Yeah, that's not correct notation. If I go with the other one, I don't think this is very clear what's my inside and what's my outside, so let me change it for you. What if I write something like this? If I write something like that instead.
Inside is X minus
Good. And which one is that, my f of x or my g of x? Good. X minus 5, and what's my outside function? Very good. That's possible. I like to keep them like in a parentheses or in a square root or in something so that an absolute value so you can see what's the inside and what's the outside. Okay. That's all we got for today. We got lots of time to do homework. You got time to work on your review. Get ready to go. Okay. Anybody have any questions for me? Are we feeling okay?
I think you do.
How did I do? I rewrote it.
Oh.
Like I just changed the.
I don't get how you find it.
I just decided in my head I wanted to be a problem. Yeah. I don't think you'll have to graph them, but you'll definitely have to find them. Mm-hmm. Any other big questions from there? You might go to the bathroom. Anything else? Okay, I'm gonna turn off the video. I'm gonna be around to help. This is your time to work on homework.